to understand why the Euclidean algorithm works, first I want you to notice that if you take two even numbers like 50, 36, 26, if you subtract two even numbers, the result is also an even number. It's also true if I take two, let's say, multiples of 7, like 35 and 14, and I subtract those, I get 21. This is a multiple of 7. 5 times 7. This is a multiple of 7. And when you subtract, you get another multiple of 7. Basically, you have some 7s, you're taking away more 7s, so the thing that remains is going to be a bunch of 7s. That property is going to be needed in understanding why the Euclidean algorithm works. To find the greatest common divisor of 2091 and 629 using the Euclidean algorithm, just to remind you, make a little chart, big, small, remainder, 2091. So we divide 629. 629 into 2091 goes 3 times. That's 8. 3 times. That's 1887. Subtract. That's our remainder. You can be sneaky here and just divide the 204 into 625 for the next 629. Sorry. Goes in 3 times, that's 612. Subtract, get 17. And finally 17. 17 becomes the new small, 204 becomes the new big. 17 into 204 actually goes in 12 times, goes in exactly 12 times. So the answer was 70. So I'll use this as an instructive example. Now, Euclidean algorithm is named after Euclid, who was a mathematician, wrote the Elements in 300 BC. And when he explains the algorithm that now has his name, he didn't say anything about dividing and take the remainder. He said if you want to find the GCD of 2091 and 629, he says first just subtract 629 from 2091. Get 1462, and then subtract 629 from that and get 833, and then subtract 629 from that and get 204. This 204 you'll recognize from right over here. It was the remainder when you divided 2091 by 625. Because that's what remainder is. Well, division is how many times can we subtract the smaller thing from the bigger thing. And the remainder is what's left over when I can't subtract any more 629. So this 204 is the remainder. Then Euclid says to now take the now that I've subtracted all the 629s, then take 629 and start subtracting away this 204 from it over and over. It becomes 425. Subtract 204 again. It becomes 221. Subtract 204 again and get 17. So when this gets less than 204, now you start. This 17, by the way, is familiar because this 17 is the remainder after you divide 629 by 204. The 17 was over here. It was that remainder. Now I'm going to start subtracting 17 from 204. And you have to subtract away a lot of them. I'll just say 119 minus 17 is 102 minus 17 equals 5 minus 17 equals 68. We're getting there. Minus 17 equals 51 minus 17. Move over here. Equals 34 minus 17 equals 17. And finally, we get down to 0. And Euclid says then that the thing that you've just been subtracting over and over is the answer. The thing I want you to notice is that because 2091 and 629 are both divisible by 17, when you subtract them, this answer is also divisible by 17. And then when you subtract 629, which is divisible by 17, from 1462, which is divisible by 17, 833 is also divisible. So every single number that you see here, whatever the GCD is, in this case it's 17, all these numbers will be divisible by 17, which means that the remainder, when you divide, is going to be divisible by the GCD, whatever that GCD happens to be. So 204 is divisible by 17, 629 is divisible by 17, that means that the difference is divisible by 17, divisible by 17, 17 is divisible by 17. And every single number in this list is divisible by 17. And they keep getting smaller and smaller until you eventually get to 0. So that means the number before was 17. That's, of course, divisible by 17. And that's the answer to the question. So looking back at the Euclidean algorithm, I hope you can see now that each of the remainders is going to be, whatever the GCD is, not only are the two original numbers divisible by it, but the remainder is also. So now the 204 becomes a smaller number, and I can keep getting numbers that are smaller but still divisible by the GCD, and therefore that's why this process works. It has to do with remainder being the result of repeated subtraction. And that's why the Euclidean algorithm works.